Hi viewers, this is the part 2 of the MCQs force and laws of motion, and part 1 is already been uploaded. You can go and check that out. So we are going to continue with the MCQs. So the next MCQ is Galileo's law of inertia is similar to which Newton's law of motion. So we know inertia is the property of a mass, and we know one of the laws which states that Newton's law, that a body will try to remain at rest or in motion until and unless external force is applied on that. So that is your first law. Next is a heavy ball is dropped from a height on a pile of sand. After falling on pile, the ball moves same distance in the sand and then stops. During its motion in the sand, the force Fw on the ball due to its weight and the force Fs due to sand, they are saying they will be equal or will be in the same direction, are such that Fw is greater than Fs or Fw is less than Fs. Okay, now so when the ball is moving in the sand, you know the speed of ball will slow down, that we already know, compared to that in air, right? So in such case they cannot be equal, right? Nor they can be in same direction, because ball will be moving down and sand will try to oppose the motion of the ball, right? Just like as we move in air, so air try to oppose our motion, or friction, just like friction, right? So answer could be either C or D. Let us find out. See, here they are saying force exerted by weight is greater than Fs, or force Fw due to motion in the sand on the ball is less than Fs. Fs is what? It is the weight. No, Fs is due to the sand. So the force exerted by sand will be more in this case. So answer should be D. That is where the ball stops. Okay, the next is, in a mass 9.8 kg, a force of 1 kg weight produces an acceleration of. Okay, so here mass is given. Let's write it down here. Mass is 9.8 kg and this is 1 kg weight. This is force. Force is 1 kg weight, which is nothing but equal to 9.8 Newton, right? So acceleration, we know force is equal to ma. So you know that you have to convert this thing in Newton, and how you can convert kg weight into Newton? By multiplying it by 9.8. So here it would be 9.8 is equal to 9.8 into a, so cancels out. A is 1 meter per second square. So make sure you mark this, not this. This is the CGS unit. After that is the next. A body of mass 2 kg moves with an acceleration of 3 meter per second square. The change in the momentum in 1 second. So this is nothing but, we know change in momentum. Change in momentum means change in momentum by time is nothing but force. And I know formula for force is ma. So basically I have to find the value of delta P, and time here is 1 ma. So m is already given to you. What is value given here? 2. Here it is given 2 into 3. So this is 6 kg meter per second square. So here, this is your answer. Next is ratio of force and acceleration measure. So you can see force is nothing but mass into acceleration. So if you divide force and what they are saying, acceleration, so F by A would be equal to mass. So answer for this question should be ratio of force and acceleration measures velocity, momentum. So it should be mass, but mass is not given, so answer will be none of these. Next is, a stationary book weighing 0.25 kg acquires a speed of 10 meter per second when hit by a hockey stick. The impulse imparted by ball. Okay, so we know formula for impulse is force into time. Okay, so see, mass is given and velocity is given, impulse imparted. Okay, so Newton second is here, 2.5 2. Okay, one thing I can write, this is nothing but change in momentum, if you remember, right, into time. So this will get cancelled out. So formula becomes impulse is change in momentum basically. So now what is the value of momentum? Momentum is mass into velocity. So mass is 0.25 given here, you can see, and this is 10 given. So answer would be 2.5 Newton second. So it should be first A part. Next is internal forces are always balanced, never balanced, may or may not be balanced. Nothing can be said about these forces. So here internal forces are the forces which are already present within a body, right? So if the forces are not balanced, of course, how the body cannot attain its shape or whatever is the position. So it should be balanced, then only the body can attain its proper shape, size and all. Next is 20. Momentum has the same unit as that of. Abhi just now I told you. See, momentum and impulse. So answer should be impulse. Momentum has the same unit as impulse. But here one thing, it should be rate of change of momentum. Right? Okay, let us find out. Let us do it once again. See, I know momentum, impulse is nothing but F into T. F is delta P by this. So TT cancels out, and what am I left with? I am left with momentum is equal to impulse. Right? Next is external forces are always balanced, never balanced, may or may not be balanced, none of these. See, external forces could be balanced or they could not be. If they are not balanced, then we will say the body is acted upon by unbalanced forces, and if it is balanced, we say the body will try to maintain its position or its, you can say, motion. So it could be balanced or it could not. Internal has to be balanced, external could be or could not be, depending on the way the body is. Okay, next is kg meter per second is associated with. So this is the SI unit of momentum. Next is, it is difficult to walk on ice because of inertia, not at all. More friction, not at all. Absence of friction, yes, this is the answer. Its surface is slippery, right? Newton is the SI unit. Okay, here the problem, Newton should have been with capital N, because if you are writing capital NEWTON, so it becomes the name of the scientist, and if it is a unit, it has to be with small n. Make sure you know that. Okay, Newton is the unit of force. Next is, yeah, see here it is written correctly. Newton equals to, so we know that that is equal to 9.8 kg weight. So thank you for watching. I hope you will find it useful and you will practice more. Let's wait for the next video.